Hi everyone. So today we are going to talk about the part two of makemore. So in this part, instead of just using a previous character to predict next character, we will use like the previous few characters to predict the next character. And from now on, we will use a more complex neural network to achieve that. And I will also go through the source code to help you understand what are those codes. Okay, and it's also a reminder of myself, help me to remember the concepts well. Okay, so I just copied the code here from this repo, make more to MLP. Okay, so at first we still need to read the words, and here's the names here, and this is all the same. And for this part, to build the vocabulary of characters and mappings to and from integers, this S to I and I to S are still the same as last lecture. But from now on, it's a little bit different. We choose this block size to to let us know like how many characters we need to predict next one. Okay, so for example, you can use you just print something to let you know. Yeah. So for example, we have Yuhan here, and it means that if the previous three is start and we have Y, and it's okay, it's no character. Okay, no Y predicts U, no YU predicts H, YUH predicts E, and so on until this ENG predicts no character. Yeah, just give you a sense that how it works. And now because we put all the words into the X and Y, and you can see that the shape here is we have 228,000 you can say pairs of this. Okay, so yeah, and here what we do is we put the 80% into this training set and 10% to validate and 10% to test data set, and we will mention that later. So now, according to the paper that in this course mentioned, he uses this C to transform a word into a vector representation. And for example, here we use this 2D vector. And because for we have 27 characters, including the no character. So we just made a random array C here. And we can see that we can just put this X here, and this will give us the after this X applied to C. And you can imagine that C is a first step of neural network that it takes this X and produces this C. But here, for like convenience, it is more easier to just use this C of X instead of build MLP. Okay, so here, let's see. Okay, so and next step, we want to combine these two two dimensions, and we use this very powerful torch dot view here, and I see that we want the last dimension be 6, which is 3 times 2, and -1 means that torch will help us compute. Okay, so this we put this 3 times 2 to, and dimension is basically means that we put like the 3 words like into a array. And because each word, each character is represented by 2 numbers, so 3 of them are represented by 6. So just you can see that the 6 is here. Okay. And well, this is our first step of neural network. Yeah, you can say maybe you can say a second because C is the first step. And the second step is we multiply with this weight 1 and add B1. That's just the first neuron. And after this pass, because we are doing like 200,000 by 6, and we multiply with 6 by 100. So here is the result is 200,000 by 100. And here we make the last step is another neural network is to build from this 100 we want to output the probability of each character. So the result we want the result to be 27 dimension. So we also create this W2 and B2 here. And we do this still same operation and get the logits. Logit means like the log of the count. And this is all just like last course. So we do exponential to get counts, and we count we sum with the we divide with the sum of the row to give probability here, and we calculate our loss by uh, negative log likelihood, the average negative log likelihood, because we put this probability here, and we take log and we take mean, take its average and add a negative here. Okay. So this in this torch entry blah 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 y just means that for each uh input, what are the one we want to take? What are the probability of the answer we want to take here? So y is the answer, like for in the last example above. So if this UHE and it will predict, it should predict n. So we are taking the, for example, if UHE is index 1. Okay, so this is our claim 1 and the n, the S2IN, and we take that probability. Because we want that if the model is great, we want the probability to be to go to near 1. Yeah. Okay, so above is the one pass. Okay, so here is how we use this training set and data set here. Yeah. Okay, so you can find here the trend shape. It's only 80% of the X, and Y is also the same. And here we use this torch generator for reproducibility. And like here is still the same. Like, and we store parameters here. And you can see that parameters is this amount. And because we need to do gradient descent, we need to set the required grad into true for all the parameters. And here is just a test for how to set a good learning rate. So basically, if you want to set a good learning rate, you can just search from, like, for example, for this one, it's just from 10 to the power of -3 to 0. It's 0.001 to 1. And because in the test, you can just see at a video that when 0.1, the loss is like relatively small than other learning rates. So the video Android picks 0.1 as the learning rate. Okay, so here is the training, and we will talk about this batch later. Oh, or maybe we can just talk now, because you want to like to take a batch means that a part of your training data and you walk a data step rather than you take all of them and walk a giant step. Because for this batch, you may want to like just adjust your paths like very often, and it means that you will be more likely to get to the right place which has minimum loss. Yep. And but if you use too smaller batch, it means that the noise will be very high, and you may just like walk around, and maybe this time you may want to try a bigger batch to make your step more further. Okay, so here is still the same. Like we use path this C from all of this ix means that the index from xtr. So here we have 32. And you can see that why here the dimension here is 10 because in the final implementation, we Andre thinks that the dimension of 2 is a little bit hard to represent. It's a little bit crowded to put 27 characters, so he changed to 10 dimension here. Okay, so now this is still the same code, but it's just because here it becomes 3 times 10, so we use 30 here. And you still calculate its logits. But here you can just use this cross entropy to replace what we just done. And you can see here for my work here, you can just use cross entropy to replace what we do here, like to exponential and to divide by the sum and calculate the negative average log likelihood. And why we want to use this? First is because this makes forward and backward more efficient. And you can see that in the 10H implementation, if we want to use it's like the e to the 2x blah 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 format, and it will pass more like calculations. But in the 10x, if we let's see here, 10H, yeah, here we just use this 1 minus t to t squared to calculate his uh to calculate its derivative, so it's much easier for the calculation. Okay, so here is the backward pass that you just set on the graph to 0 and in PyTorch is none. And then you do this last step backward to do the backward pass. And so here's for the update part. It's still the same. You just tell your gradient times the learning rate. But here we do something like when you train more steps, like if your learning rate is still a comparatively large number, it means that your step will still be bigger, and sometimes you won't get to the lowest spot, which means you won't get to the minimum spot. So here we reduce the learning rate to make sure that we can converge very well. And here this step I and last I is just for drawing the graph. Okay. So after the training, you can see that this is a training loss. And we want to validate. So we use the other 10% data to validate our model. So here is the loss here, and it seems that pretty good. Okay, this graph is just Android want to show that the representative, the two-dimensional representative for 27 character may be somewhat learned by the model, because you can see that the vowels are at the left bottom. Yeah. So here it shows how to sample the model. So basically, we just need to put this context. Here means that the three the three initial character we put in, and we put into the C, and also we just do this forward pass, but we doesn't do cross entropy. We just need the probability here, and then we do multinomial to sample it. Just sample one, and then we move the context window and we output the character we sampled. And until we sample, if we sampled to the 0 means that the dot here, then we break. So here's the result. It seems more like name than what we done before. Yeah, before I think it's this one. Yeah, this one here. Because now we have our model is more complex, and now we use more previous information to predict the next information. Okay, so I think that's all for this video, but let me see if there's something I want to mention. Okay, So this is what I wrote, what I practiced when watching his video. So, okay, so here he mentions another way to do this. You can do this torch unbind to make the dimension disappear. But this view is more convenient because it doesn't change the actually elements in the memory. So using this view, you just change its view, and it's more like more energy, if more efficient way to do this. Okay, so let me check if there's anything I want to say. Oh yeah, maybe I can just say that how I beat the 2.17 here. So Andre left us as a homework to beat this. And what I do is just I increase the batch size here to make one step more bigger. And yeah, and I trained more rounds. Yeah, because this makes the noise more less and somewhat avoids that you just like walk randomly, and it will like in this way it will give the result will give you like more correct path to walk. But if you use two bigger batch, it means that you each time it means that you walk fewer steps, and likely you need to to balance like how much step you want to walk and how long the step you want to be. Like this is just a hyperparameter you need to tune. And also this learning rate is also a hyperparameter. Yeah, and I think there's nothing more I can say here. Yep. So I think that's all for today. Thank you.